Good morning, everyone. One of the debates out there in math is whether your students should read the question first or the problem. If you read the question, which the expectation or the skill is based from, it points you in the right direction. Sometimes reading the question doesn't help as much, but if you read the question first and then go back and read the problem, then are required to read the question again, your chances of truly understanding the question and what it's asking is going to increase. The question that we're going to look at today has a key word in the question, and I know that some people don't believe in keywords, but I'm just going to say honestly and truthfully in love, those people don't understand that we can't treat all kids the same. If I have trouble reading an entire paragraph, I'm going to struggle with reading a problem. And a problem is a bunch of sentences in order with a question to make a paragraph. So by all means, let's start our kids who struggle with reading at the sentence level by reading the most important sentence, the question. And if your students would have done this on a question that's like this one, anywhere in the United States, they would have already been heading the right direction instead of the opposite. And the two other things that made this question more difficult was that it was multi-step and it was also requiring a grid response. So the students had nothing to guess and check with. So let me share some strategies using a fifth grade question. Since it was readiness, it means that your students could have and should have learned it in fourth grade. It also means that if fifth graders went into sixth grade only with only 25% of the students understanding how to do a multi-step problem like this, then we should practice and get extra time or extra times on these types of problems. So let's go ahead and read the question first. And then we'll read the problem. And as we do that, we'll underline and we'll label in both places the information that we need to solve the problem. What is the area length times width in square yards of the pier that Bill built? Okay, so whenever we see area, we're using two-dimensional shapes. And so a pier is, yes, a three-dimensional shape because it has depth, it has a height, so it has volume. But when they're only asking about the top portion of the pyramid, that's two-dimensional. And as soon as my students saw the word area, they would respond verbally and kinesthetically with length times width with their mouths, and they would do length, making an L, times width with their hands. So we know that we're not doing perimeter, we're not doing volume. We've got to find out the dimensions of the pier so that we can draw them. And if we read from top to bottom, we'll just dissect it as if it's 1, 2, 3 pieces of a puzzle because of the, let me see, 1 period, 2 periods, 3 periods, 3 sentences. Bill was building a pier over a river near his house with the shape of a square on the section connected to the land. So I already stopped and I drew a picture with a little wavy line with the word land on it. Here's the picture of the square and the shape of a rectangle out over the water. So there's my rectangle, and I drew the word water, and then they're going to give us the dimensions. The square section was 10 yards in length. So I went ahead and wrote 10 yards on one side of the square. Knowing that we're asking for area, length times width, we can already solve the area of the square part because the pyramid is both parts together. 10 times 10 is 100. And because we're using two dimensions, it would be yards squared or square yards, if we're going to put it in words. You're not done because the pier is also built using the rectangular shape. It had a length of 20 yards and a width of 12 yards. There's your 20 and there's your 12. So we've got to also do area length times width to figure out the second area. So using the shortcut with zeros, 12 times 2 is 24. And then all you have left is a 0. So the product of 20 and 12 is 240. So that's 2 steps. The third step, because we need the area of the entire pier, since the keywords yards and yards are the same, if they would have given 1 in feet and 1 in yards, we would have had to have done a conversion first. But now all we have to do is add up the sum of 240 yards and 100 yards, and we would get 340 yards. So we would place a 3 in the hundredths place, and right away you see I put it in the tens place. A lot of kids will think ones, tens, hundreds. No, that would have already been wrong. And so I'm using a pen which says, let's always use a pencil when we're writing on paper, and let's be careful where we put the number when we're doing our online responses, because we don't want to start in the wrong place, because then all the other answers would be wrong. So the answer is 340. So it would be a 3 in the hundreds. And then so that I don't forget, I'll go ahead and bubble in the 3, because if I were to guess, when the computer is looking at the students' responses, they're going to be looking at the bubbles, not necessarily the numbers up here. Now, when we can change to all online, it's going to be able to detect words and everything. So that will probably change next year. 40 and nothing else. So it might be a good idea just to practice understanding that after every whole number is a decimal, whether it's written there or not. The area of the pier is 340 square yards squared, and no other tenths and no other hundredths in order to solve this problem. And so that there you have your answer, the 3 steps that your students would have had to have gone through. And on the question that was like this on the test, the picture was actually drawn for your students. So I made it 1 step harder because they would have to draw the picture. And remember my acronym ARMS, or reading anything is actors remember more story sequence or artists remember more setting and senses. So since we're trying to see what the pier looked like, drawing a picture of it would have helped those kids of yours who struggle with reading like the entire puzzle. Let's just handle one puzzle piece at a time. So the E, we've executed our strategies. There's not three answers to eliminate, but there were three steps to execute: finding the area of the square, finding the area of the rectangle, and then adding the sum of the two areas together. So then we're going to go to the grid response and submit our answer in both the box in the right position relative to the decimal and in as we circle the bubbles. And then we're done. So there you have it. This next one has to do with prime numbers. So just if you watch a little bit later, I'll work on prime numbers with you. And one thing to help your students remember on prime is think of prime one time every time. And I guess I can go ahead and do it with you since it's just right here in front of you. That they were asking, prime numbers are like prime ribs. They can be very rare, not to find, but in the way you cook them. But with today's economy and inflation, maybe it would be rare to find prime rib as well. Jonathan was asked to list all of the prime numbers between 40 and 60. His list is shown below, which two prime numbers are missing. So we're already want to practice multi-step when there's more than one correct answer. So you would be circling more than one. And I already have a program where I'm going to be giving you tests now in the new online format where you can do multi-answers, short answer, fill in the blank, lots of variations of tests. So when it says which two prime numbers are missing in the list, the list that's given is 43, 47, 51, and 59. Let me check something real quick. 17 times 3. 7 times 3 is 21. Times 1 is 3 plus 2, 51. Oh, I made a mistake on this one because 51 is not a prime number. All right. 52, 53, 54. 59. Yeah, I think I made that mistake. So when you do this one with your students, go ahead and see if they can catch my own mistake. Make sure they eliminate the 51, and we'll use the 3 as the list. And so when you try that, the idea is just to try it because the rule is prime one time every time. So the extra question would be which one in the list is wrong and which two are missing. So the one that you remove would be the 51 because in my brain I was able to suddenly see that 51 has factors of 1 times 51 and 3 times 17. So as soon as you realize that it's not 1 times something every time only, then you got to eliminate it as a prime number. Since 53 only has 1 times 53 and nothing else, and that if that's every time you do it, then that is a prime number. 61, 1 times 61, nothing else makes 51. So those are the two answers, but we also have to eliminate the other choices. 57 is 1 times 57, yes, but 3 times 19 is also, because when we did 3 times 17, we got the 51. 3 times 18 was 54, but 3 times 19 was 57. So since we have more than 1 times something, then we know that that's not one of the prime numbers that's missing. And the same thing applies here, where 1 times 55 is 55, but you also can get a product of 55 when you multiply 5 times 11. So with my mistake that I made in the answer choices, that was an accident, it wasn't on purpose. You can help your students do better than 42% by remembering that the word prime 1 time every time means that only 1 times the number itself as factors can make that number the second one as a product. So there you have the list. So now we have 1, 2, 3, 4, 5 prime numbers here that we can practice. And we have 1, 2, 3 numbers that are not prime numbers. So as we read it, we'll underline, label, execute the strategies, eliminate the 3 wrong answers, and select one in both the book and the Scantron. If you're working with prime numbers, this is a supporting standard. That means we should know prime numbers by the time we get to 4th grade. So if less than half of the kids got it correct, that means if you have 6th graders, they probably struggled with this. So for this last week and these last weeks of May, I would highly suggest that you do multi-step problems and that you work with prime numbers, because as you can see, 25% correct as a 5th grader is extremely low, and not knowing all of the prime numbers, I would probably suggest that you have your kids just make a list, prime numbers on a piece of paper, and then write all of the prime numbers they can think of from 0 up to 144, since a lot of times multiplication is done up to your 12. So just an idea for you. Do me a favor and share or tag your friends who are teaching math for this video. Save it in your computer somewhere for when you're working on prime numbers or multi-step problems with area. And I look forward to working with many of you in math, reading, writing, or classroom management and motivation this summer and coming school year. God bless and take care.